So, I'm going to start with a little story. There was a guy named Magdeburg that had a little, like a little circus. And I'm going to simplify the story, but pretty amazing guy. And he went around in Europe hundreds of years ago, like this. So this guy Magdeburg had one of these little circuses, and he'd go around in Europe, and he was a genius. He was an absolute genius at getting people to sacrifice their money to him. And he invented something called the Magdeburg spheres, which he really didn't understand the science, but they were great. And what he had were, he had two spheres, and they were pretty big, like this, two halves of metal, and he put them together, put them in a fire at night, and get them really, really hot when they're stuck together. That made the air get really hot, and hot air takes up less space. Hot air expands. So the hot air would expand, and when it's really, really hot, there's not a lot of air inside because it's expanded. Then something kind of advanced for the time, a valve. You know, again, he would just plug a hole. So we would have it in the fire, really hot, a little hole in it. The air would expand, come out. He'd put the plug in and take the spheres off the fire. Now the air would cool inside and outside. Well, the air outside was under a lot of pressure. The air inside, there was very little air inside. Okay, so there was very little air pressure inside because he had pushed the air out by heating it. So little pressure inside, a lot of pressure outside. And that made it very difficult to pull his spheres apart. So I want you two to try. They will come apart, so don't smack the people next to you. I hate pop it up loud. But just pull it apart. Maybe I wasn't clear. You separate the two halves. Okay? Okay. That's pretty sad. Air pressure is about 15 pounds per square inch. We'll learn about that later. But if you have a 4-foot diameter sphere, you're talking about thousands and thousands and thousands of pounds of pressure holding it together, the air around it. And if there's very little air inside, the air around it's got more pressure than the air inside. All the local people would come and they'd bring their couple of pennies they had to spend or whatever, and they might buy a meat pie and watch a juggler or something, right? Big deal for them. Okay? Think of the state fair in one room. I was going to bet somebody a penny that I could pull these spheres apart and they couldn't. Okay? But it doesn't work very good, right? Well, some big bruiser kid would come up or somebody and go, oh, I'll do that. And he'd be like, no, I don't want to. What if it works? I'll take your penny. I don't want to do that. So of course take that. And they'd pull and pull and pull. Here I have two of you. Imagine one big person, you know, and it's 100 times the volume. You'd never get it apart. Okay? So they'd pull and pull and pull, and they couldn't get it apart, and he'd kind of walk up and pop this little valve open, and air would push in, the higher pressure of the room would push into the lower pressure inside. Once the pressure was equal, he'd pop it apart, and they'd be like, oh. A lot of them lost a lot of money to this guy already. They're like, we're going to get him. So what do you think they brought? What was the most powerful thing that farmers had at the time?
A tractor.
Really? Tractors 200 years ago?
A horse. A horse.
A horse. Oh, what tractors? Right. Yeah, TVs too and remote control. All right, so they would bring their horses, and Magdeburg would make a big deal. Oh, no fair! You can't. Oh, no horses, no fair. And they'd hook up horses to one side and a bunch of horses to the other side. And they'd beat those horses and get them to pull. They couldn't pull it apart. And he'd walk up, hide the little valve, pop them right up with this. But yeah, and again, what's a valve and what's air pressure and what's that hissing sound? They don't know what a hissing sound is, except maybe what comes out of the back of a cow, you know? So none of it would register as anything odd, okay? All right, so that's the story of Magdeburg. So our goal today is to learn about air pressure. There are two terms that are used incorrectly, I would say 99% of the time by human beings, including many scientists and engineers. I go through this all the time. They use the terms incorrectly. They believe the wrong thing about it. And the two words are suction. Nothing in the universe sucks. It's physically impossible to pull air or pull a liquid. You cannot. You can only push air or liquids. The other term used inappropriately almost all the time is vacuum. Vacuum is used as a term, oh, I vacuumed something up. The vacuum of space. As far as I know, that physically doesn't exist anywhere in the universe. Okay? I hear engineers, and we get into this at conferences, and some of your parents are engineers, and I love it when they come up and go, negative pressure. How can you have less than 0 atoms? can you have less than nothing? How can you have less than zero pressure? Think about it. And sometimes I look at engineers and go, think about it. And they go, ah, yeah, I see what you mean. Yeah. But they've been taught in colleges. I was taught vacuums and suction and all that's wrong. Okay? They don't exist anywhere in the universe. First, we're going to talk about what is air, since we're going to talk about air pressure. Air has two incredibly simple, in-your-face, obvious properties. So it'll probably be a challenge for some of you guys, but it's going to be really obvious, okay? I'm going to demonstrate the simplest, easiest thing to see about air. Okay? Because again, we live in it. We don't realize it's there. I'm going to prove to you there's air around us. I have an empty balloon, pretty much. Okay? Here, I'm going to demonstrate a property of air. It's awe-inspiring. Calm down.
Oh my God!
Ooh. What did I just show you about air?
It exists.
I didn't make air expand. Air has volume. It takes up space. Thank you. I didn't make air get bigger. I just took air from here and put it in there. And then the balloon got bigger. So I added air to the balloon got bigger. Air takes up space. It has a volume. People don't understand that. What? Yeah. Air fills things up. Air is something. You're used to living in it like a fish in water. You don't realize it's there. Okay? Takes up space. Pretty awe-inspiring. Okay, number 2. Okay? Now, incredible property. 1, air takes up space. So we see it taking up space, right? Did you see? I put stuff in the balloon got bigger. If I take it out, balloon gets smaller. Okay, air take up space. The other thing we're going to see is, did anything change about the mass of my balloon from it being empty to being inflated? So what's the other property of air? Air takes up space and air has mass. All with a balloon. Pretty easy, huh? You know more about air than most people realize. And the less air is pushing on you. Okay? If you go up really high, there's very little air pushing on you. If you go up to the top of the atmosphere where the space shuttle is, there's essentially no air pushing on you. What some people would call the vacuum of space.
No such thing as vacuum.
That's right. All you can have is very, very low pressure. Just everything's different in pressure. You can only have low pressure. You can't have less than 0 pressure. Okay? So the higher you go, the less air, so the less pressure. More air pushing on this guy, less air in this person, less air in that person. Just it's intuitive, it's easy, and it's just obvious. Okay? Makes sense. All right? Remember that. It's real easy to understand air pressure. All right? Look at this balloon. And again, this all gets very complicated. All right, what I'm going to do is I'm going to push the air out of this chamber, and it's going to come out here. It's just a very powerful, fancy fan. And again, it even says on here, it calls it a vacuum pump.
There's no such thing as vacuum.
It can't create 0 pressure. It can reduce pressure. So I'm going to create real low pressure in here. I have a hose connected to it. So the higher pressure in here is going to go into here. The pressure right now, inside and outside, is equal. You know why? Because I can take this off. Well, let's see what happens. Hopefully all my equipment works. Yeah, looks like it is. I'm reducing the pressure around my balloon. But the pressure in the balloon is still at 15 pounds per square inch, but the air around it's at less pressure now. So as I raise that balloon up to a higher altitude, it's under less pressure. So the balloon gets bigger. If I bring the balloon down to a lower altitude, it would be under more pressure and it'll get smaller. If I apply pressure, it gets smaller. If I reduce pressure, it gets bigger. Oh yeah, I'm reducing the pressure. By the way, notice I can pick this all up now. Air pressure's holding it on the container. I'm reducing the pressure on that balloon, And so it's slowly getting bigger and bigger, and it's still getting bigger. Those of you that are up close can probably see it's getting dramatically bigger. That's why I have to paint things on it so you can tell. Okay? And again, this is where the air is being pushed out. Remember the magic word, push. Alright? So we brought this balloon up to like Mount Everest. Okay? Why don't they fill up weather balloons?
There's no need. Is the pressure?
What's going to happen? So do you want to have it fully inflated before you launch it?
No.
So it tries to expand?
No.
Or do you want to leave it room to expand? Like this, needed room to expand. If you've got your balloon fully inflated and it starts to go up, it's going to pop. So you don't fully inflate it, so as it rises up, it can get bigger. And all weather balloons at high altitudes are big round balls. At low altitude, they have that shape. You have to leave space. Ooh, are you worried about the mega explosion?
Yes,
Okay, first of all, where there's less air, there's less sound. You get sound by air molecules hitting your eardrum. That's why in space there's no sound. That's why the first science fiction movie ever to show that was 2001. There's no sound in any scene that's space because there's no molecules to hit your ears. Oh, we should probably stop. We're up against your camera. All right, let's bring this balloon to a lower elevation, okay? All right, so what I'm going to do is I'm going to turn the pump off, and there's a valve, but I do this really fast, so I just have a piece of tape here that covers it instead of a valve. So I'm going to pull it off, and you're going to hear the air being sucked out.
No such thing as suction.
That's right, right? What you heard is the air being pushed in. Remember, air can only push, so it got pushed in. You might
The kites and planes and butterflies have things in common. One's the sky. They all can sail through the air, and birds can too without a care. Pressure, 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 pressure. And it's pressure, and it's moving all around us. And it's grooving, now it's changing. Inner pressure, creative that we can measure. Yeah, yeah. High. Wings are